12:8, last lesson of the chapter, combinations. So when you're dealing with permutations here, think like opening a safe, for example here. If it's 135, I mean, you got 135, 153, 351, 315, 513, 531, right? These are permutations, by the way. So, yeah, it's a little weird when you think it through here. But permutations here, each one of those is different. The order matters. If the combination's 531, well, if I enter in these other 5 numbers here, the thing is not going to open, right? So it has to be in that order. If it's not in that order, well, then you're punching in something else altogether differently here. So when we're talking about combinations here, think like a pizza, where if I got pepperoni, sausage, and mushrooms, okay, those are your choices, and you pick 2 of those 3 toppings. So you got pepperoni, sausage, and mushrooms. So I could have pepperoni and sausage pepperoni, pepperoni mushroom, mushroom pepperoni, mushroom sausage, or sausage and mushroom there. Again, still like the letters, there's 6 different permutations available to us there, right? But if you're ordering a pizza, whether you get, say, pepperoni and sausage or sausage and pepperoni, it's kind of the same pizza, right? I mean, what's the difference here? It doesn't matter if we put on the what we say. You're going to get the same pizza one way or the other. So when you're dealing with combinations, what we're trying to do is we're trying to get rid of all the duplicates, because they are, in this case, the same. So things like this one, that one's out because it's already right there. The pepperoni mushrooms and the mushrooms pepperoni, well, again, the same thing's already there. And the mushroom sausage and mushrooms, the same set of toppings is right there. So really, we don't really have 6 choices for how we can do the pizza. We have 3 choices, right? Do you agree with that? So the way we're going to set it up, and we'll practice this here, is to figure out how many combinations there are. What you need to know is the number of permutations. And again, if we figured it out here, there were 3. First topping, 3 choice. Second topping, 2. Third topping, 1. That's where the 6 came from. Just like up here, if I, again, 3 letters, 3 numbers, same kind of setup going on here, but there were 6 permutations. But then we need to divide by the number of arrangements. And when I say number of arrangements, what I'm talking about is, of these 3, we chose 2. And that's going to be the big thing here. You're going to see here, choose 3 of the 4, choose 2 of the 6, choose 6 of the 22, choose 15 of the 24. So you're going to see this choose thing coming on here. But if I'm choosing 2, then for number of arrangements here, again, I got 1 of 2 toppings to be my first choice, right? For arrangements here. So I would have 2, and then my second topping, I would only have 1 choice available. And if I do 2 times 1, I get 2, and ultimately the number of permutations was 6, divided by the number of arrangements 2 toppings. Topping 1, topping 2. Divide those 2 numbers, what do I get for the number of combination? There were 3 combinations, actually, of how many different pizzas, and there they are right there. So by dividing by the number of arrangements here, kind of similar to the factorials, when you're dividing by the number of arrangements, you're always going to end in times 1. Always. Because if I'm using 3 of 7, well then at the bottom, when whatever however I arrange those 7 in groups of 3, well then on the bottom here, the first number is going to be 3, 2, 1 choices here. So I would divide by 6 here. So this is the part that gets a little confusing sometimes here, how this works out here, but it's going to come back to whatever this number is here, and you're always just going to multiply basically a factorial of whatever that number is. You're going to multiply all the way down to times 1. And you guys have been really good at your permutations here. You seem really good about figuring that part out, and we still got to do that. To figure out combinations, that's your top number here. But for combinations, we have to take it a step further. And what we're doing here by this is essentially eliminating the duplicates. The book kind of shows it another way here. They talk about this. Your friend is going to paint his basement, 6 cans of paint. You're going to use 2 of the 6 colors. How many different combinations could you make? And again, with paint here, whether I use the red and the white or the white and the red, that's the same paints. Doesn't matter what order I pick those 2 paints out in. So they kind of go through, show it all off here, but I mean, you can think it through. So that problem there, he's got 6 paints, he's going to use 2, but it doesn't matter what order they in. So for the permutations, my first paint choice, I would have 6 choices, right? And then the second paint, I would have 5 choices. All right, I'll just say paint, 6 kinds, use 2. All right. So basically I have 30 permutations here. And that includes red, white, and white, red here. They would all be there. In the book, I'll show them all in a minute here. But then for the number of arrangements, since it doesn't matter, well, once I get them all in there, basically for my arrangements here, if I just say I got white and red, the order I put them, I can either use the white or the red first. I got 2 choices. And then whatever's left is whatever I have left. So I had the third.
2 times 1 on the bottom.
Well, if I was using 3 of them, well, then it would be 3 times 2. If it said 6 paints, use 3 of them,
So it was choose the
that
other
would
one
be
you use.
6 times 5 times 4 divided by 3 times 2 times 1. Because first paint choice, I got 6 choices. Second paint, I got 5. Third paint, I got 4. And now I got my 3 paints, whatever they may be, but then the order I have them, I already have 3 paints decided at this point. The first of the 3 could be one of 3, the second, and then whatever's left here. So this would be, again, 6 kinds, use 3. Because for the order of paint here, it doesn't matter. But 30 divided by 2, basically I would have 15 different paint combinations available to me. Not 30. This one here, I'd have 120 divided by 6. I would have 20 different combinations if I use 3 of the 6 for the paint here. So the book, again, kind of shows briefly here. They list all the different permutations here. There's all 30 of them right there of the 6 red, yellow, blue, green, violet, and white. There they all are there. But in the red here, they kind of cross out the duplicates. Those are all the duplicates there. Yellow, red is the same thing as red, yellow, and so on and so forth here. But we did have 30 permutations, 6 times 5. First paint choice, 6. Second paint choice, 5. But then going through, how many ways can I arrange the 2 of them here? Well, on the bottom, yes, my coffee time, wonderful. You guys are excellent people. Low on words, but high on coffee production. You can take that there. You're always so awkward, it seems, about it.
They walk in there like.
Where's Emma? Is she not here today? It's my normal gal.
Thank you, Mr. Melcher.
Does it have a good day, Dad?
They have no.
What does that say?
Have a good. I think they crossed out day and tried to write it again.
Oh, I thought it said have a good day, Dad.
This is great.
Yeah.
Showcase.
It looked like the first day was fine. Maybe they wrote have a good pay. Maybe that was the problem with it
Have a
the
good
first
day,
time.
Dad.
Have a good pay. And they're like, wait a second.
Have a good payday.
I think that maybe that was the problem. Well, anyway, so by then taking, there's my permutations here into the two paints to eliminate it. Number of permutations, two paints, blah, 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 blah. Number of permutations of two paints. Because that's how many we're using. 2 times 1. Number of permutations of two paints. So, and then you can see 30 divided by 2 is 15. And you can see again how it would look if, same deal, if I had 6 paints. We won't list all 120 options out, but again, number of permutations of the 3 paints, 3 times 2 times 1, 120 divided by 6. You'll always get whole number answers here when you're doing these things here. You're never going to get some weird decimal type thing here. It's always going to be math magic here, dividing all this stuff. It just always will work out for you. I promise you that. So if you get some strange number here, you definitely something went wrong for you. Something on the setup here. So again, permutation's still necessary for the top, but again, some of these things here you have to just kind of consider. I don't know if they ask you too much. Combinations, tree diagram or permutations can be used in a number, blah, 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 blah. Maybe it's 8th grade here. Permutations, blah, blah, blah. How many permutations are there? Combinations. Let me look at the word problems here. They kind of mix up the word problems a little bit. It's not definitely going to be a combination. There could be a permutation in there too. Again, I may have done the quiz similar here. It may not be a given. So you have to consider, does the order, is this like opening a safe, like your street address? 123 Main Street is a totally different place than 321 Main Street. One will take you to this place and one will take you to that place. So when you're talking about like your address here, well, 123 could be one of 6 different locations, depending how you shuffle those numbers about. That would be a permutation. All 6 of those things are different. But go back to, again, the pizza or the paint choice or something here. Whether I take the red and the yellow paint for my picture or get the pepperoni and sausage for my pizza, it's the same as yellow, red, same as sausage, pepperoni. So sometimes you got to just kind of consider, you know, are these all different? If I get rid of the duplicates, does that matter? If it doesn't matter, or if, you know, all the duplicates you need, like an address, well, then you're doing a permutation. But if the duplicate is the same thing, whether I do it this way or that way, well, then you're dealing with a combination here. So I guess that's all I have to say on that. So why don't we try a few out here. Number 3, you do not have to make an organized list unless you really want to. I wouldn't want to. But I'm more interested in finding the number of combinations here. So 2 of 6 pens seems eerily similar to 2 of the 6 paints that we have just done here. So hopefully we all can say the answer is 15?
15, yeah. Oh, say 60. Did you say 60?
60.
60?
Oh, wait.
60.
Choosing 2 out of 6 pens, again, that would be, if I lay 6 pens out here, whether I pick my blue pen and my purple pen, doesn't really change the fact if I take my purple pen and my blue pen out, right? I'm still, the order I pick up the 2 pens doesn't matter. I'm just picking 2 of the 6. I'd probably pick the
Yeah,
red.
I would have gotten that if I didn't do 6 times 7 times 4.
6 times 7 times 4.
Yeah, I was kind of being a little crazy.
6 times 7 times 4, Eve did.
Yeah.
Where did you get that?
All right.
I don't
Well, try number 5 here. There we go. Give me a moment. So choose 5 of the 15 apples. Does it matter that the order the apples are in?
No.
Not really. Because if I got a bucket of 15 and I'm taking 5 home, the order I pick those 5 doesn't change which 5 I'm walking home with. Right? I'll give you all a moment here. I'll pull a stick. Let's see what you come up with here.
Wait a minute.
Number 8, by the way, gets a little intense.
Yeah, I see that. I was looking at that.
Won't lie to you on here, on that one there.
I think I got it this time.
I don't think I got it this time.
5 of 15 apples. Yeah. We'll find out here in a moment. What you think? All right. So, what do you think, Eve? 3003. How'd you get 3003?
So I just did 15 times 14 times 13 times 12 times 11, and I got 360,360. And then I did the bottom part. I did the 5 factorial thing,
Yep.
and got 120 here. And then I divided
You
it.
did 2 division. There are 2 multiplication things on the 2 and 1.
What?
The multiplication sign,
bottom
the
part?
X's,
Oh.
and 2 and 1.
Huh.
The heck, Mr. Mulder? That'd be a
How
syntax
much?
error.
And then I got
Hmm.
120.
And you got your 3003.
Oh my god, Mr. Melcher, what are you doing?
Zero on the
What are you
bottom
doing,
part.
Mr. Melcher?
What?
It's not 12, it's 120.
Oh, 120.
Oh my god. Drink that coffee. Drink the coffee.
Yeah, that's exactly correct. How you did this here, and that
Mr.
is the
Melcher,
correct
I think I
answer.
got number 8 on the homework. I think I did it.
Well, I look forward to hearing it on Monday.
I think I got
Keep it to yourself there. Yeah, it's a chunky one. But yeah, this is the setup here. This is exactly how the rest of you do with it.
that. I did it that way.
You guys all got it?
Yeah.
Yeah. So again, of the 15, first choice, second, third, fourth, fifth choice, again, 10 apples will be left off to the side. That's where the other 10 are. And then of those 5 apples, how many permutations of the 5 apples are there? Now I have my 5, 5, 4, 3, 2, 1. It will always end on your bottom times 1, always. However many you're choosing, it's just going to be a factorial on the bottom there. And yeah, that's really good. Number 7, choose 2 letters from the word math. You do not need to draw a tree diagram.
Thank you. 'Cause that on number 8 would be.
It says determine whether a tree diagram or permutations can be used. One of them, a tree diagram, might be more useful.
You
than
know
the
how when you
others.
put something like really big into your calculator and it puts like the times whatever? It got times 18.
Yeah, I think as you're
So-
figuring out 8, you'll probably end up in scientific notation on the top line before you're done with it.
Yeah.
So
Yeah. Yeah. Yeah.
it's a little intense. So let's see what you can do. All right, number 7. Choose 2 letters from the word math. Doesn't say how many different ways can I arrange the 2 letters. In that case, AM and MA would be different. Just says choose any 2. Throw them in a bag and pick 2. That's it. So the order doesn't matter. I'm only picking 2 letters. It's not they have to be in any specific order. Just pick 2. If I was taking 4 of you and I said, how many ways could I put you in order for first, second, and third place? Well, that's a permutation because first, if you're first, second, third, well, that's different than you being first, second, third.
I'm first, second, and third.
But if I said just pick 3 of you to go on a card ride with me to Ventures, that would be a combination because whether I pick you, you, and you is the same as picking you, you, and you to go in the car with me, right?
What about me?
In that case,
You're gonna just stay here.
right,
Colin's number-
Colin will stay here, so.
Or you can go with
But in that case here, first, second, third place, that would be a permutation because they're all different places. The first, second, third, and fourth, third, second is it's different there. But if it's just get in a car, it doesn't really matter. You get to go, you get to go, you get to go, you get to stay here.
Yay!
Right? It doesn't matter then. Those would be the order I pick you. Either I pick you first, second, or third, you're still going in the car. Right? Okay. So of the math, how many different letter choices are there, Colin?
I got 6.
6. How'd you get 6?
I did 4 times 3 over 2 times 1.
Yeah. So first letter choice, second letter choice. There's 12 permutations available, but now we're just picking letters. Doesn't matter the order I pick them. So whatever 2 letters, there's 2 permutations. Whatever the first letter is, I got 2 choices, and then whatever letters last. Yeah, 6 it is. 6 it is. All right, backside. 9. What is this about? Complete the table
Ew.
showing the products of possible of rolling 2 number cubes. Well, you can do 10. All you need to do is what's 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1.
Well, there's so many.
That's too hard.
Forward to your amazing table and math skills, right?
Can we do it in the book? What about these
Well, you
other?
just build a little table. You can just go 1, 2, 3, 4, 5.
What about these other blocks?
Hey, this one you have to multiply stuff, so
What
you have
about
to figure out like 3 times 3 and stuff.
for the other?
This is you only have to do 3 plus 3, huh?
For the other ones, do we have to do 2 plus 2? 2
That's all you have to do. 2 plus 2, 3 plus 5, 4 plus 7, right? You just add all the numbers together.
Okay.
Right. Okay. Dice kind of. Okay. Yes, you can do that one there. Right. All right. Number 11 here. What permutations the outcome of the roll results in a product greater? Well, that deals with that. 12. You have to figure all that out. What combinations of outcomes in a product and a sum are less than 10? They're saying which of these combinations up here will produce a result with a sum that is less than 10.
Most of them.
Well, there you go. You can just kind of highlight them or draw a little line or circle them or something when you build your table. Obviously, you don't need to figure out the products because you're not doing 9. Product deals with question 9. So just figure out, once you fill in your table, just circle all the ones that have a sum. That's the answer to your addition problem, by the way. That is less than 10. Great. 13. Use a calculator to solve. Sounds good.
Wow.
School is choosing 2 new school colors. They can choose from red, blue, green, gold, maroon, silver, orange, white, black, and purple.
Oh.
A lot of choices. How many different combinations can serve as the new school colors? Still got 2 more sticks and I got 2 more problems here. So.
I got it.
2 new school colors. They can choose from a lot of colors. Might have been easier to list the colors they can't choose
For
from.
number 15.
Okay. Let's see, a couple are still punching away here on 13, pondering their response. All right, Sam. How many?
45.
45. That is correct. How'd you get it?
So you put so there's 10 different things.
Yeah.
So it's 10 times 9 on the top, which is
Yeah.
90. And then it's 2 times on the bottom, you divide it, and then boom.
Right, that's exactly right. So you need to figure out how many there are. 10. First color, I got 10 choices. Second color, I got 9 choices. And then of those 2 colors, how many different ways can I arrange them? Well, I got 2 choices, and then whatever I got left is my other one. So 45, it shall be. All right, 15, you're probably already working on it. Mr. Jackman was packing 60 different lunches belonging to students on a field trip in 4 different boxes. How many combinations of lunches can he pack in the first bunch? Look forward to this one here.
It's just the last one.
So 60 different lunches going into 4 boxes. Can you pack in the first box? 60 different lunches belonging to students on a field trip in 4 different boxes. Any pack in the first box. I don't understand. I got a different answer. What did you get? 147?
Which one? 15?
Right.
I got 4,800, or at 4, I got 487,635.
Yeah, I got that too.
You know, I'm still not totally clear how the book. Here's what the book got. You ready for it? And
No.
again, I'm trying to figure out where this answer came from. 'Cause honestly, I don't know. Here's what the book got.
Bro, how did, what? They got, how they get that many? What is that?
You know, they
How
got
does it get
53
what?
trillion, 194 billion, 89 million, 192,720.
Maybe they did 60 factorial.
Maybe. I don't know.
What in the heck, bro?
Well, I did 60 times 59 times 58 times 57
Needs to
Divided
write
by
it down.
divided by 4 times 3.
Yeah.
What's
So,
60
Mr.
factorial?
Morgan, Maybe answer is us.
Well, then now 60 factorial is that. And then I must divide by 4 factorial, maybe?
I got
Oh,
40.
that gives me that number.
487,635.
Yeah, that's what we got.
I don't really know what's going on here,
What?
to be honest with you. So.
We all win.
I'm not even really clear. I don't understand the question real well. So. Anyway, I guess we'll be confused. So apparently, according to the book, it's 53 trillion. So
That's not.
I don't even know. I'm trying to figure out how we even got that number in the first place, period.
Should we just like call it? Should we
I
just
don't
call
know.
it and say that this is correct and that's not?
Well, whatever.
Bye.
Fine.
Okay. Well, anyway, I think.